Hello and welcome. I'm Felix and I'm a hobby game developer. What you see here is my current game project that I've been working on for about a year now. Today the game is still far from finished, but I finally see it coming together and I'm optimistic about being able to finish it. In this first video I want to introduce the project and show you what I've created so far. I had the general idea for this project several years ago. I wanted to create a game set in the future where you live in a colony on another planet, tasked with farming, mining and producing supplies to sell to Earth. Automation and a fluctuating economy were two of the biggest gameplay focuses. At the time I was mainly inspired by Minecraft mods such as thermal expansion. I just loved creating, improving and scaling up fully automated production lines. However, I felt that most mod packs made it too easy to create infinite quantities of power as well as many resources. Later, I would also draw inspiration from Factorio and Stardew Valley. I think that these games both excel at giving you goals without forcing you into a specific playstyle. Before I show you my game in detail, I'd like to take you back in time. I tried to build a game on this idea once before, and I made a lot of mistakes. Back then I was learning to program for a few years and I felt confident enough to create a game. In reality, I was overconfident. The scope of the game quickly grew. It was supposed to feature an entire galaxy to explore, large-scale planets consisting of procedurally generated 3D voxel terrain, and of course, multiplayer. Everyone with experience in the field is probably already crying, but I assure you, it gets even worse. As a cherry on top, I was writing my own game engine from scratch using only Java and OpenGL. For anyone not into programming, let me illustrate that for you. I was basically setting out to create my own space program from nothing but sticks and stones. Went about as well as you would expect. I console myself with the fact that historically, software engineering and good estimation skills do not seem to have been made for each other. Unfortunately, I don't have any footage from that game, but I found this image showing one of the early planets from space. My enthusiasm kept me going strong for a surprising amount of time, and I did make slow but steady progress on that project. But after 2 years, I finally had to face reality. I was doing what most inexperienced developers do, underestimating the scope of the project. Massively. I made some very rough estimates, leading me to conclude that I would not be able to finish this project in a lifetime. Consequently, I cancelled it. Initially, that hurt. I had poured so much time and passion into this project and now I would have nothing to show for it. But eventually, I realized the fun I had developing as well as all the lessons learned were far from nothing. And because I don't know what's good for my sanity, I soon started over. But whenever I needed to make an important decision, I thought first about development effort, then about gameplay. I wanted to make sure I can finish the game this time by limiting the scope. The gameplay just doesn't matter if the game never gets finished. To constantly remind me of that, I gave it the working title Project Simplicity. During the last year, I mainly programmed many of the systems the game will need and tried my hand at drawing pixel art. Before we jump in, just keep in mind that this is all still very early and there is missing and broken stuff everywhere. The game is based around an in-game time system. You play through a year 1 day at a time. I have not yet implemented seasons, but the game already has a day-night cycle. A simple illumination system makes it possible to have light sources in the game. The player character is one of these light sources, so you can always see what you are doing. And one of the things you will be doing is farming. Farming is going to be the biggest source of raw materials. You are going to need raw materials to feed your factories. Currently, farming is still very simple. You just till the soil with your hoe and put some seeds into the ground. For the crops to grow, you need to water them daily. Right now, there's only one crop, but I will definitely add more. For production, I currently have one machine, the cooker. It can turn berries into jam. While you could use the machine manually, ultimately you will want to automate it, so you can focus on farming or whatever else you want to do. To do that, the game currently has conveyors and mechanical arms. The arms can be used to move items between machines, containers and conveyors. I think it's quite satisfying to watch. Of course, all these machines need power. For now, you can use a generator fueled by coal. Power distribution is done via power pylons. Once built, you can connect them with a cable and they will provide power to everything in a 2-tile radius. By now you have a decent overview over the current state of the game, but I don't just want to show you what I created, but also how. Every devlog I would like to give you some technical insight into one of the game's systems or effects. Don't worry, I will not show too much of my spaghetti code, if at all. But I do want to give you a decent idea of how I go about solving some of the problems I faced in development. Ideally, I will talk about what I implemented for that devlog, but as this is the first one, I have an enormous amount of stuff I could talk about. I chose to highlight one concept that caused me quite the headache: scene persistence. The way the game is built, every map is a scene. The farm is one, so is the house interior, and the village I plan to add soon will be as well. Persistence requires two things. Firstly, when the player revisits a scene, all changes he made need to still be there. So if we put a machine down on our farm and leave, it still needs to be there when we return later. The solution to this is straightforward at first. The scene just needs to be saved. However, this is a lot harder to implement than one would think. Unfortunately, Unity does not provide any help with this, and I had to create my own system. My most important requirement was that the system had to be as modular as possible, because the data that needed to be saved varies a lot between different types of game objects, but still some objects share the same scripts. For example, a machine consists of mainly two scripts, one for the production logic and one providing an inventory. Ideally, I could use the same code for saving an inventory, no matter what object it is attached to. I decided on using JSON and wrote a custom serialization port. This port is added as a script component to every game object that needs to be saved. There are two versions of the script, a simple one that only saves type and position, and an advanced version that scans the game object for every script component that has special save data. All these script components implement a custom serialization interface that allows the port to interact with them. The port can be used in both directions, meaning it can populate the object from a given JSON string or it can turn the object into a JSON string. Right now, the JSON strings are simply stored in a global class, meaning they get lost in between game restarts. But in the future, I can easily save them to disk to create permanent save games. The second requirement for persistence is that while the player is away from a scene, time still needs to progress in that scene. For example, if the player has a machine running on the farm, spends some time in the house and then returns to the farm, the machine needs to have continued to run, or at least it has to look like it was running. Unfortunately, I cannot just assume that the machine produced X items per minute and call it a day, because the machine may depend on other machines. Let me try to illustrate this. The setup here is very simple but could break that solution. The mechanical arm feeding the cooker is a bottleneck if it is too slow compared to the cooking speed. So the solution must look at the entire production line. I briefly considered writing a system that turns a scene into a graph of machines and works its magic on that, but I did not want to have duplicate code for these machines and I wanted to keep it modular. What I ended up with works like this. Every game object affected by time has an interface that allows me to apply one time step, or tick, to the object. When the player enters a scene, it is loaded and then all time steps since the player's last visit are executed as fast as the processor can before letting the player into the scene. So if the player has been absent from a scene for 100 ticks, the game will execute that interface method on every game object in the scene and repeat that 100 times. Additionally, the method is also used in most game objects' update method, meaning that all time-dependent logic is bundled into this one method. So by now you hopefully have an overview of the current state of the game. I'm currently working on creating a small village with a few traders that I want to show you in the next video. If you want to know more about a specific system or its implementation, or have any thoughts on what I'm doing, feel free to leave a comment. I'm Felix, and I hope to see you next time.